The question I would like to address in this module is how do we take sensory information from the world around us, from our environment, receive it, and then somehow turn that information into some kind of mental recreation of what is out there so that we can interact with our environment and make appropriate choices, from simply not bumping into objects and injuring ourselves to very complex behavior like seeing the face of someone, recognizing an expression of sadness on their face, and perhaps deciding that we want to pause whatever we are doing to offer our support. See, look at this image. It probably took you a heartbeat or less to recognize what's going on. But how do you know what goes with what? I mean, there are many lines on this image. Why do you see some as being part of one item, one object, and others as being part of a different object, say the rows versus those planks? Even though, notice, there's substantial overlap between the position of the lines that make up one object versus the lines that make up the other object. In fact, how do you tell where one object starts and the other one ends? Also, very, very clearly, you seem to be perceiving one object as being in the foreground, and I'm guessing that is a rose, and the other object as being in the background, the planks. But why? Why is that what everybody watching this video is perceiving? How does your brain make that determination? Finally, again, it took you less than a heartbeat to recognize what those two objects are. There's a flower in the foreground. In fact, it's not just a flower, it's a specific type of flower. You probably recognize that as a rose. And yet, I'm guessing you probably haven't seen very often roses on wooden planks. In fact, this is not the regular environment in which you would expect to see a rose. So what mechanisms allowed you to understand that object for what it is? And same for the planks. First, you are seeing those things in the background as planks that are sort of going away from you in depth. Why? I mean, you could have interpreted them as shapes or sort of pieces of wood that are sort of large at the bottom and just thinner at the point, and they're going vertically instead of sort of away from you in depth. But I'm fairly confident what you saw and what you see when you look at this image is planks that sort of run away in the distance. Why? Right? How does your brain reconstruct, and I'm using the word reconstruct purposefully, what objects are out there? See, as we have seen last week, this is really hard to do with a computer. It's very hard to teach a computer to do what you did with no effort and less than a heartbeat. So seeing what is there turns out to be, when you think of everything that goes into it, a pretty complicated affair. Take this other image. It probably took you, again, less than a heartbeat to recognize that what's going on is that somebody is holding a shiny sphere, and inside that shiny sphere, you can see the reflection of the person holding the sphere, in fact, Mr. Escher, famous artist and painter. And you can also see part of the room that is behind him. But how did you do that? Why did you interpret this, I don't know, like somebody having their hand nearby a window and the window peeking into a room that has a person looking out and just has a weirdly shaped bookcase in the background and has a weirdly shaped wall? I mean, it could be somebody could build a wall that I'm sure there are houses that have that can be built with walls that are sort of smooth and curvy instead of straight. And yet, I'm rather confident that most people in this room, either say everybody that is watching this video is interpreting this image the same way I did. And see, again, it's about computational complexity. There are so many possible interpretations of what is often very ambiguous information reaching our senses from the environment, often due to the fact that the world is three-dimensional, but our retina is two-dimensional, and somehow we have to infer and reconstruct what is out there in 3 dimensions. And yet, despite all of this complexity and ambiguity, we all tend to see the exact same thing. It's a miracle. That's what our brains are for. That's how our brains learned to cope with the world. In fact, you can notice this process of reconstructing the world, which we'll get a little deeper into during this lecture, if you consider this image. Now, it's not easy to see this the first time. If it's the first time you've seen this image, you might not see it automatically. And really, this is an image of some splotches of black and gray and white. But if you look at it a little bit more carefully, in fact, if you don't see anything in here, enjoy it, because it'll be impossible for you to unsee what I'm going to show you. But if you're not seeing anything here, you might instead consider that if you look more carefully, there is a cow in this image. I think it is a cow. Here, let me help you. Right. So now, in fact, I'll just go back. Now you probably see there's a cow in there. And obviously there's no cow in this image. It's a flat picture on a screen, so there definitely is no cow. But your perceptual system and your cognitive system cannot help but organize those splotches of white, black, and gray into a shape that makes sense. In this particular case, a cow. And you can make, you can take several examples like this. You can look at this image. It looks like it's sort of a landscape of snow and brown grass. But if you look very carefully, right here, you will probably notice some horses. You can see here the legs of these horses. And these are just 2 interesting ways of demonstrating the fact that our brain actually is trying to reconstruct and is making an inference about what is out there. How does this happen? Well, we should start from the fact that there are 2 basic ways that our brains interpret information when it comes in through our senses. First, we refer to bottom-up processing. So that is sort of our minds come equipped to receive information from out there and apply to that information a series of transformations that allow to turn patterns of light on your retina, or patterns of pressure waves in your middle ear in the case of audition, and to turn those stimuli into a mental representation of some kind of object that might be out there. And this flow only uses sensory information that you're receiving from out there in order to reconstruct what is there. So you're literally taking what is reaching you and you're processing it, and you're only using that information in order to try to infer what is out there. This is referred to as bottom-up processing. So from the retina, sort of up into the brain and up through the cognitive hierarchy. Now, compare that to so-called top-down processing. Now, see, the idea is that you already know a lot about the world. The kind of objects that exist out there, the kind of things you might encounter, the kind of sounds you might hear and that items might produce. So what you already know can guide, can bias what you're perceiving. So what you already know will synergize and bias bottom-up processing. And we will see some wonderful examples of this, both in this module with respect to vision, but also later on with respect to language. So in this sense, what you already know is biasing, is influencing the bottom-up processing. And this serves you very well because it can help you resolve the typical ambiguity, and thus it can help you resolve what is else a great computational complexity in the context of receiving information from the world and understanding what that is. Now, when we talk about perception and sort of understanding rather the world from out there into in here, we do separate 2 important aspects of this process. One is sensation, and the other one is perception. Sensation is literally the conversion of physical properties of the world, so energy from out there in the world, into the neural code. See, every different, we're going to discuss this in a little more detail, but every different every different sense that we have is a specialized organ to receive some kind of energy, for example, in the case of vision, photons, and transform that energy into the language of the brain. The language of the brain happens to be electrochemical signals. So sensation is the process of taking a physical energy from out there in the world that carries some kind of information, what we would consider visual information or auditory information, and it transforms it into the language of the brain. And this is a highly specialized and fairly inflexible type of machinery. On the other hand, the process of taking this sensation, taking this energy that has been transformed into electrochemical signals and turning that into a meaningful representation of what can be out there, that is the process of perception. So we can separate, energy from out in the world reaching you and being converted into some kind of a signal that your brain can work with, and the treatment of that signal, which, as we said, can operate both in a bottom-up way and in a top-down way. Now, using the schema developed by Gibson, you can think of this this way. Perception occurs when some informational medium, the energy we were discussing earlier, carries information about some object out there in the world to a person, you, somebody who's going to receive that information. Now, when the person's senses pick up on this information, proximal stimulation occurs, or in the language of neuroscience, you might know this as transduction. And this results eventually in the formation of a mental representation of the perceptual object. And I know this is a mouthful, so let me break this down with an example. Let's do this by modality. Okay, let's take the modality of vision. So vision, so sight. Let's take a distal object, the face of somebody you love. This is the object in the world, what Gibson calls a distal object, something that is out there. Now, of course, something needs to bring the information of that distal object to your senses. In the case of vision, we're typically talking about a very specific form of energy. That is, the reflected light or the reflected photons from the object out there in a very specific spectrum of the electromagnetic range. In other words, light hits the distal object, in this case, the face of somebody you love, and it reflects it towards you. So now photons are carrying information of the distal object to you. Then that's when, once this information reaches your specific organs, whose job is to receive this information, in the case of vision, it's your retina, these photons get absorbed in the rods and cones of your retina, the cells inside your retina that receive information, and they translate that information, or in the words of neuroscience, they transduce that information from photons into electrochemical signals. So something that your brain can work with. And finally, your brain then takes this information and employs both bottom-up and then top-down processes in order to reconstruct, to infer what is out there in the world. What is the perceptual object? So you recreate a mental representation of the distal object. And the schema does feel a little bit tedious, but it does show very nicely the various aspects that are involved in receiving information from the world and processing it. In fact, it also very nicely separates the aspect of sensation. So the idea of converting a specific form of external energy into a specific form of internal signal, which just happens to be an electrochemical signal in the case of neurons. And it separates that from the idea of perception, which is the building, the representing of some kind of what is out there inside here. And it does this starting from the pattern of proximal stimulation. If you think of it, all that your brain has in order to understand what's out there, in the case of vision, is the pattern of photons that are hitting your rods and cones. From photons reflected by something out there hitting your retina, you have to reconstruct what is out there. So these are sensation on the one hand and perception.